Benzoyl peroxide /ぃPEN registered trademark ppERXID is an organic compound in the peroxide family. It consists of two benzoyl groups bridged by a peroxide link. Its structural formula is C6H5CO2O2. It is one of the most important organic peroxides in terms of applications and the scale of its production. Benzoyl peroxide is used as an acne treatment, for improving flour, for bleaching hair and teeth, for polymerising polyester and many other uses. It is on the World Health Organization's list of essential medicines, a list of the most important medication needed in a basic health system. Uses: most benzoyl peroxide is used as a radical initiator to induce polymerizations. Other major applications include its antiseptic and bleaching properties. Acne treatment: benzoyl peroxide works as a peeling agent. It increases skin turnover, clearing pores and reducing the bacterial count as well as acting directly as an antimicrobial. It may be combined with salicylic acid, sulfur, erythromycin or clindamycin, and adapalene. Two common combination drugs include benzoyl peroxide clindamycin and adapalene benzoyl peroxide, a unique formulation considering most retinoids are deactivated by peroxides. Benzoyl peroxide for acne treatment is typically applied to the affected areas in gel or cream form, in concentrations of 2.5% increasing through 5%, and up to 10%. Research suggests that 5% and 10% concentrations are slightly more effective than 2.5%, while 2.5% is usually better tolerated than the 10% concentration, though the majority of major studies comparing it to other treatments use the higher concentrations. Benzoyl peroxide commonly causes initial dryness and sometimes irritation, although the skin develops tolerance after a week or so. A small percentage of people are much more sensitive to it and liable to suffer burning, itching, peeling and possibly swelling. It is sensible to apply the lowest concentration and build up as appropriate. Once tolerance is achieved, increasing the quantity or concentration and gaining tolerance at a higher level may give better subsequent acne clearance. Other common uses for benzoyl peroxide include dyeing hair, tooth whitening systems, the preparation of flour, an initiator and catalyst for polyester thermoset resins, as an alternative to the much more hazardous methyl ethylketone peroxide. A hardener in order to start the polymerization process in resins. For instance, PMMA resins can be polymerized with benzoyl peroxide. In the U.S., the typical concentration for benzoyl peroxide is 2.5% to 10% for both prescription and over-the-counter drug preparations that are used in treatment for acne. Higher concentrations are used for hair bleach and teeth whitening. Benzoyl peroxide, like most peroxides, is a powerful bleaching agent. Contact with fabrics or hair can cause permanent color dampening almost immediately. Even secondary contact can cause bleaching. For example, contact with a towel that has been used to wash off benzoyl peroxide containing hygiene products. Side effects: concentrated benzoyl peroxide is potentially explosive, and can cause fires without external ignition. The hazard is acute for the pure material, and for this reason, the compound is generally used as a solution or a paste. For example, cosmetics contain only a few % of benzoyl peroxide and pose no explosion risk. Studies have highlighted the carcinogenic potential of benzoyl peroxide. A 1981 study from the journal Science concluded that caution should be recommended in the use of this and other free radical-generating compounds. In a 1977 study using a human maximization test, 76% of subjects acquired a contact sensitization to benzoyl peroxide. Formulations of 5% and 10% were used. Synthesis, structure and physical properties: benzoyl peroxide was the first organic peroxide prepared by intentional synthesis. It was prepared by treating benzoyl chloride with barium peroxide, a reaction that probably follows this equation: 2C6H5CO, Cl plus bar O2 C6H5CO, 2O2 plus bar Cl2, Benzoyl peroxide is usually prepared by treating hydrogen peroxide with benzoyl chloride. The oxygen-oxygen bond in peroxides is weak. Thus benzoyl peroxide readily undergoes hemolysis, forming free radicals, C6H5CO, 2O2 a 2C6H5CO2 a eurocent. The symbol a eurocent indicates that the products are radicals. That is, they contain at least one unpaired electron. Such species are highly reactive. The hemolysis is usually induced by heating. The half-life of benzoyl peroxide is 1 hour at 92 AA degrees Celsius. At 131 AA degrees Celsius, the half-life is 1 minute. Benzoyl peroxide breaks down in contact with skin, producing benzoic acid and oxygen, neither of which is significantly toxic. It is important to note that the safety of the decomposition products does not mean that the substance itself is safe, as it is benzoyl peroxide's action as an oxidizing agent that is of importance. Hydrogen peroxide can be corrosive due to its oxidizing properties, but decomposes to form water and oxygen. Sodium hypochlorite also shares these properties, but disproportionates to form harmless products such as sodium chloride. References. External links: International Chemical Safety Card 0225, NIOSH Pocket Guide to Chemical Hazards 0052, SIDS Initial Assessment Report from the Organization for Economic Cooperation and Development, Benzoyl peroxide, Re-evaluation of some organic chemicals, hydrazine and hydrogen peroxide, IARC Monographs on the Evaluation of Carcinogenic Risks to Humans 71, Lyon, France. International Agency for Research on Cancer, 1999, ppA 345 €58, ISBN A92-832-1271-1A.